Hey everyone, welcome back to another Edexcel IAL math past paper video. Today we're going to talk about the January 2025 Pure Maths P1 paper. So let's jump into the paper. Question number 1. Find the integral of 8x cubed minus 6 root x minus 2 over 5x cubed. So first off, what we need to do is to rewrite this in the index form. So you have 8x cubed minus 6x 1 over 2 minus 2 over 5x raised to power minus 3x. Now it's straightforward. Power raised by 1 divided by that minus 6x 3 by 2 also divided by 3 by 2 minus 2 over 5 x raised to power minus 2 divided by minus 2 plus c. So 8 divided by 4 is just 2 x raised to power 4. 6 divided by 3 by 2 is just going to be 4. Right? 6 divided by 1.5 is just 4. X 3 by 2 and the 2 and the minus get cancelled, so you have plus 1 over 5 x raised to power minus 2 plus c. That's it. Alright, so let's move on to the next question. Question number 2. Given that the point A has coordinates minus 2 root 3 5, point A, point B has coordinates 7 root 3 8. Straight line L1 passes through A and B. Show that the gradient of L1 is P root 3, where P is a rational constant to be found. Okay, so first off we need to find out the gradient. 8 minus 5 divided by 7 root 3 minus root 3. So you get 3 over 9 root 3. Since there's a square root in the denominator, we have to rationalize it. So we get 3 root 3 divided by 9 times by 3, 27. So this becomes 1 over 9 root 3. That's it. The straight line L2 is perpendicular to L1 and passes through A. Right. Find the equation of L2, giving you an answer in the form y is equal to mx plus c. So very straightforward. So the gradient of the line perpendicular to L1 would be negative reciprocal of this, so minus 9 root 3 basically. Minus 9 root 3. Because originally this thing was also, 1 over 3. So this is 1 over 3 root 3. So this becomes this, minus 3 root 3, right? So y minus y1, m x minus x1. We plug in the values. Y minus y1 is passing through A, so 5. And m minus 3 root 3 x minus or x plus 2 root 3. So y minus 5 equals to minus 3 root 3 x and minus 6 times by 3, 18 plus 5, minus 18 plus 5. So you get minus 3 root 3 x minus 13. And that's about it for this question. Let's move on to the next one. Question number 3. The population of a town was monitored. Exactly 5 years after the monitoring began, the population was 58,000. Exactly 10 years after the monitoring began, the population was 65,000. Given that the population of the town P in 1000, T years after the monitoring began can be modeled by this equation. Okay, so P 1000, so you have to take care of this. Where A and B are constants. Find the value of A and the value of B. So we have two unknowns and we need to use these two equations. So T is in years but P is in thousands, right? So A would be, first equation would be 58 squared equals to A plus B 5 cubed, and the second one is 65 A plus B 10 cubed. Okay, so this simplifies down to 58 squared 3364 A plus 25B, 125B, and 65 squared 4,225 A plus 1000B. Okay, so let's subtract both of these. So 4225 minus 3364 equals to AA will be get cancelled, so 1000B minus 125B. So 1000 minus 125 is 875. B equals to 4225 minus 3364, 861. So B is going to be 861 divided by 875, 0.984. Okay. Now for the A would be 3364 minus 125 times by 0.984. So 3364 minus 125 times by 0.984. So this is 3241. Okay, right. So therefore A is 3241. V is 0.984. Okay. 4. According to the model, exactly T years after the monitoring began, the population was 85,000. Making your method clear, find the value of T, giving your answer to one decimal place. Okay. So we have P squared 3241 plus 0.984 T cubed. So 85,000, right? 85. That means this is 85. 3241 plus 0.984 T cubed. So basically this means that at T is equal to T, P is equal to 85, right? So we do T cubed would be equal to 85 minus 3241 divided by 0.984. Oh, sorry, this is 85 squared, 85 squared. So 85 squared minus 3241 divided by 0.984. We'll leave it as it is, right? So 166,000 divided by 41. So T is going to be cube root of this value. So cube root of answer 15.9. What did we need it as? One decimal place. 15.9 years. Right. Okay, so let's move on to the next question. Question number 4. Given that y equals to a raised to power x, expressed in the simplest form in terms of y and a raised to power 3x plus 1. Okay. So what we have is y equals to a raised to power x, right? And we need to figure out what a raised to power 3x plus 1 means. So if you split it, this is a raised to power 3x times by a, and this is further a raised to power x cubed times by a. Right, so a raised to power x is y, so this is ay cubed, right? That's simple. 5 over 3a 1 minus x raised to power minus 2. Okay. 5 over 3a 1 minus x raised to power minus 2. Okay, so first off, rewrite it as 5 3a 1 minus x squared. So multiply the square. Deal with the square first. So 5 times by 9, a 2 minus 2x. Simple factor rule. So 5 times by 9 is 45. A 2 minus 2x. So we'll solve the a 2 minus 2x like this. So a squared over 2x. So this is your a squared and this is your y squared. So this is your 45 a squared over y squared. Use the substitution p is equal to 9 raised to power t to show that this equation is equal to, can be written like this. Okay, so what I'm going to do is I'm just simply going to copy this and paste it right over there. Right, so we need to simplify this in terms of p. P was, once again, 9 raised to power t. Nine raised to power t. And we have this in terms of 3, right? So 9 raised to power t means this is 3 raised to power 2t. Okay, so let's figure this out. One by one. So 3 times by 3, 4t plus 2 plus 3 equals to 82 times by 9 raised to power t. So 3 times by this basically means 3, 4t plus 3, because one more 3 added, and plus 3 equals to 82 times by 3 raised to power 2t. This thing, 4t, 3 raised to power 4t is actually the square of 3 raised to power 2t. So this is, you can say p squared. And this is your 3 times by, 3 cubed times by 3 raised to power 4t plus 3 equals to 82 times by 3 raised to power 2t. Now we substitute it back. So 27 p squared minus 82 p plus 3 equal to 0. That's it. So we just simply rearrange. So this was minus 82p plus 3. Right. Okay. Hence, solve this equation. So that means solving this equation is like solving this one. So we solve this one. This is part C. This is part C, right? Oh, sorry, part 2A. This is part 1. This is part 2A, and this is part 2B. So first off, we solve this quadratic equation. I think it's possible this would be solved by sum and product rule. 3 minus 82p. This is 27, so 9 times by 3 could work, and this is wait, no, we need 81, huh? Right, so 27, 1, so 27 times by 3 is 81, and this is that, right, okay, so you have 81 p and p, so both of them have to be negative, like this. So 27p squared minus 82p plus 3 can be written as 27p minus 1, p minus 3. So hence, this implies 27p minus 1 is either equal to 0 or p minus 3 is equal to 0. So therefore, this means that this is either 1 over 27 or p is equal to 3. We need the values in t, right? We need the values in t. So this is 3 raised to power minus 3, and p is equal to 3 raised to power 1, right? So p itself is 9. So remember that 3 raised to power 2t is either 3 raised to power minus 3 or 3 raised to power 2t is equal to 3 raised to power 1. So this means that either 2t is minus 3 or 2t is 1. So t is either minus 3 by 2 or t is equal to 1 over 2. Now the equation has been solved. Alright, so let's move on to the next question. Okay, so question number 5. The curve C has equation y is equal to 4x cubed plus 2 over x plus 9. Okay, find dy by dx. So this is straightforward. So first off, we rewrite this function with the index form for the x minus 1 plus 9. Now we can easily do the dy by dx. So dy by dx would be 3 times by 4, 12, x squared plus minus 1 comes down, so this becomes minus 2, x raised to power minus 2 plus 0, because the derivative for 9 would be just simply 0. And this is the simplest form. Okay, you can rewrite it like this: 12 x squared minus 2 over x squared. Both are simplest forms. Given that the point P lies on C, that means it satisfies this equation, and the line with equation y is equal to k minus 5x, where k is a constant, is a tangent to C at P. That means at P the gradient is minus 5. Okay, show that the x coordinate of P satisfies the equation, right? Okay, so at P, dy by dx is minus 5. Okay, so that's what we just want to do. We just need to form the equation. So 12 x squared minus 2 over x squared equals to minus 5. So first thing we can do is we can multiply both sides by x squared, giving us 12x raised to power 4 minus 2 equals to minus 5x raised to power 2, and then we bring everything on one side, making it into 12x raised to power 4 plus 5x raised to power 2 minus 2 equal to 0. And that's what we just had to show. Find the value of k. So now we need to solve this. So for that, we'll say let u be x squared. So this transforms into 12u squared plus 5u minus 2 equal to 0. So let's try solving this with the basic sum and product rule. So you have u squared minus 2 plus 5u. So if we do 3 and 4, right, so 4 times by 2, 8, 3. The only way we can get a positive if 3 is negative. Right, so you get 3u plus 2, 4u minus 1 equal to 0. So either u is minus 2 over 3 or u is 1 over 4. Remembering what u stands for, u is the positive x squared, just x squared, and x squared, square numbers are always just positive. So x squared is either 2 over 3 negative or x squared is 1 over 4. This one, however, yields no solutions. This one leads to x is plus or minus 1 over 2. Okay, so we can't just use 1 over 2, we have to use the minus 1 over 2 also. Unless there is a condition. Unless, yes, they specify that x is greater than 0. So since x is greater than 0, x is equal to 1 over 2. Right? Okay. Right. So we now need to find the value of k. So we have found the x value where the gradient is minus 5. So now we need the y value also. So y value at 4x cubed plus 2 over x plus 9. That was the function. Yes. Okay. So this becomes at x is equal to 1 over 2. Sorry, why am I good? So 1 over 2 cubed plus 2 divided by 1 over 2 plus 9. 4 divided by 8 is 1 over 8. 2 divided by 1 over 2 is just 4. Plus 9. So this becomes 1 over 8 plus 1 over 2, 1 over 2. Okay, so you can make them 2, 2, 2, 2 also. So this would be 2, 1 plus 8 plus 18, so this would be 18 plus 9, 27 over 2. Okay, so this is the y value. Now we need the value of k. So the line y equals to k minus 5x passes through 1 over 2, 27 over 2. So we plug this into this function. So 27 over 2 k minus 5 times by 1 over 2. So therefore k is 27 over 2 plus 5 over 2. So this would be 32 over 2, which is 60. So therefore k is 60. Okay. Okay, done. So let's move on to the next question. The curve C has equation y is equal to f of x. Once again, x is greater than 0. Given that the point P, 4 minus 5 lies on C, and f of x is basically this, right? They've given us the, right? The gradient of the tangent to C at P, once again P is this, is 7. So, 7. Show that 4a plus b is 24. So, in short, what they mean is that f prime of 4 is 7. That's what they mean. So, now we need the equation 2x squared. So, wait, I think I can just simply take a screenshot. Right. Okay. So f prime of 4, this is going to be 2, 4 squared plus a times by 4 plus b, and then 4 multiplied by square root of 4. So you get 2 times by 16, 32 plus 4a plus b equals to 4 square root of 4, that is just 2, so 4 times by 2, 8. And this is equal to 7, right? So we multiply 8 on the other side, we get 32 plus 4a plus b equals to 56. So therefore 4a plus b is equal to 56 minus 32. So this would be 24. So 4a plus b equals to 24. Right, and that's what we needed to show. Given that a plus b is minus 9, find in the simplest form f of x. So basically we need to find the value of a and b. So the b part, so 4a plus b is 24 and a plus b is minus 9. Right, okay. So we solve these two equations simultaneously. So we subtract the second equation from the first. We get 3a equals to 24 plus 9, 33. So a is 11. And therefore b would be minus 9 minus a. So minus 9 minus 11. This would be just minus 20. So the equation becomes, okay, no, wait. This is just the f prime of x, huh? Right, okay, so we need to integrate this. So therefore the f prime of x becomes, I'm going to write it as the fractions split up. So 2x squared over 4 root x plus a was 11 for root x plus b was minus 20 for root x. So root x is 1 over 2, and since it's divided, it's minus 1 over 2. So it's 1 over 2 x. 2 minus 1 over 2 is 3 by 2 plus 11 over 4 x divided by square root. This is just 1 over 2. 1 minus 1 over 2. And 20 divided by 2, 5. And x minus 1 over 2. So now when we integrate this function, (11 over 4 x 1 over 2 minus 5x minus 1 over 2 dx. So when we integrate, the powers are raised by 1, so this becomes 5 over 2 divided by 5 over 2 plus 11 over 4 x 3 by 2 divided by 3 by 2 minus 5x 1 over 2 divided by 1 over 2 plus c. Okay, so right. So 0.5 divided by 2.5 is 1 over 5, simply, plus, I think it would be just 11 over 12, but divided by 1.5, yeah, 11 over 6, sorry, yes. Three by 2, and this would be just 10 x 1 over 2 plus c. So now we need to find the constant of integration, which we will find by this point, because this lies on this function. So at x is equal to 4, y is equal to minus 5, so therefore minus 5 is equal to 1 over 5 for 5 over 2 plus 11 over 6 for 3 by 2 minus 10 for 1 by 2 plus c. So this is 1 over 5 c. 4 square root is just 2. 2 raised to the power 5, 32 plus 11 over 6. Once again, 4 square root is just 2. 2 cubed is 8 minus 10 times by 2, 20 plus c minus 5. Okay. Now, to resolve this, you can multiply both sides by 30. Okay, just to get rid of these denominators. Or even if you don't do that, then that's perfectly fine, because we just need the value of c. So we just take everything on one side. So c is going to be minus 5 minus 32 over 5 minus 88 over 6. This can be rewritten as 2 times by 3, 4 times by 8. So 44 over 3 plus 20. Okay. Right, so 20 and minus 5 becomes 15, but let's divide them all by 15. So 5 over 15 times by 15 times by 3 times by 3 times by 5 times by 5 times by 15. So 5 times by 15 is 75. 32 times by 3 is 96. 44 times by 5 is 220. And wait. Yeah, okay. And 20 times by 15 is 300. Okay, so now we just need to do that. So minus 75, minus 96, minus 220 plus 300. That is minus 91 over 15. So the f of x is 1 over 5 x 5 over 2 plus 11 over 6, 3 by 2 minus 10 x 1 over 2 minus 91 over 15. Okay, that was the last part. Okay, so the curve C is transformed to the curve with the equation y is equal to f of x minus 3. So basically this is translation by 3, 0. Given that the point is transformed to the point Q, say the coordinates of Q. So yeah, alright, so we just need to rewrite what we just said. So this f of x minus 3 is translation by 3, 0. Therefore P 4 minus 5 transforms to 7 minus 5. Right? Okay. So that's about it. That's your C part. Okay, so moving on to the next question. Question number 7. The curve C has equation y equals to 2 over x minus k, where k is a positive constant. Sketch the graph of C. Okay, so this is easy. Oh, no. So minus k means that this is the asymptote. So just like this. The graph, however, will and it goes like this. Okay, so since you're doing this on paper with pen and a pencil, you can adjust it better. Like this. Right. Okay. So this continues down. Right. So now we label this. This is our y-axis. This is our x-axis. This is our y equals to minus k asymptote. Okay, so this is your minus k, right? And that's it. the coordinates of any points of intersection C with the coordinate axes. Okay, so we need to figure out this particular point. Okay, so we have y equals to 2 over x minus k. So when y is equal to 0, k would be 2 over x, or x would be 2 over k. So this is our 2 over k. Alright, that's it. We'll be getting that in terms of c, so no worries. The line L has equation y equals to minus kx minus 6. Given that L intersects C at two distinct points, find the range of possible values of k. Okay, so if k is like this, so either this means that this is beyond this point, that means like moving this way further, or it's below this point. Okay, so either that or so that means it's not in this particular region. It's not in the empty region. So that means it's below this point. This is the minimum point that we can have, the tangent, right? So it's going to be below this. And over here, once again, there's a tangent point over here. This is going to be above this. Alright, and since, so since this is intersecting at two distinct points, so we just equate the two equations together. So minus k x minus 6 equals to 2 over x minus k. Right? Write this. Okay. So we multiply both sides by x. Okay. So this gives us kx squared minus 6x equals to 2 minus kx. Right. So furthermore, this becomes minus kx squared minus 6 plus k, or you can say k minus 6, x minus 2 equal to 0. This is fine for us, but you can switch the signs also. So this would become k x squared plus 6 minus k x plus 2 equal to 0. Now we apply the b squared minus 4ac. So b squared minus 4ac is greater than 0 because it's intersecting at 2 points, two distinct points. So you get b squared is 6 minus k whole squared minus 4k 2. So 36 minus 12k plus k squared minus 8k greater than 0. So once again you have a quadratic equation in just k. So k squared minus 12 minus 8 minus 20 k plus 36 greater than 0. So 9 and 4. No. I think 18 and 2 would give us that answer. So k squared 36 minus 20k, k and k, 18, 2. Yeah, if both of them are negative, you will get minus 18k minus 2k. So you are getting k minus 18, k minus 2 greater than 0. So critical points are 18 and 2. So 2 and 18. So greater than 0 part would be right over there. So therefore k is either less than 2 or k greater than 18. Okay, right, and we can now delete these because we don't need them anymore. You can, okay, so since we just like wrote it this way, like specified this also, you could specify this coordinate as 2 over k comma 0. And what else? This is your origin. Okay, and oh, wait, I just realized k is a positive constant, right? So that means it also has to be greater than 2. So where should we use this? Right, okay, so right over here I think we can use that. So you can use you can modify this to be 0 k 2 or k greater than 18, because k was positive, so it has to be greater than 0. Right, okay, now I think the question is done. Let's move on to the next question. Figure 1 shows a sketch of a design for a badge. The design consists of a triangle OAB joined to a sector OBC of a circle with center O. So this is the sector, this is the triangle. OB is 3.4, AB is 1.9, angle AOB, this particular angle pi by 6, and angle OAB is greater than pi by 2, right? Making your method clear, find the size of the angle OAB, giving your answer in radians to 4 significant figures. Okay. So, looking at this triangle over here, we need the angle OAB, so we can use the sine rule because we have one pair of opposite angle and side, so we need this one, right? So using sine rule, we have sine of angle OAB divided by 3.4, sine of pi by 6 divided by 1.9. So sine of OAB becomes 3.4, 1.9. Sine of pi by 6 is 1 over 2, so you can leave it like this. So sine inverse of 3.4 divided by 1.9 divided by 2, this is, we need it in radians. So this is 1.1078, or like in the exact form, sine inverse of 17 over 19. However, notice that this is smaller than pi by 2, right? So this is smaller than pi by 2. So what we do, since we need greater than that, so what we will do is get the greater than. So just simply, how do we do that? Simply using this. So if this is acute angle and we need angle greater than, so what we do, just simply pi minus this answer. So pi minus this. So since angle OAB is greater than pi by 2, it is angle OAB equals to 2.0337 wait, sorry, how many significant figures? 4 significant figures. Okay, so 2.034 radians. Okay, so this one is going to give you a cubed. For the other one, for the obtuse, you have to do the pi minus that. Okay. Find the area of the triangle OAB in centimeters squared, giving your answer giving your answer in 3 significant figures. Okay. So for this one, we need the included angle between the 3.4 and the 1.9. So this is 2.033 or pi minus that, and you have pi by 6 as the other, right? So the angle OBA is pi minus pi by 6 minus pi minus sine inverse of 17/19. Okay, so that means you can change the signs. This would become plus. So pi minus pi get cancelled. You have minus pi by 6. So sine inverse of 17/19 divided by, minus pi by 6. So you get which is approximately 0.584. We don't need this angle as it is. We need this in the form of area of triangle. So area of triangle OAB, half times by 3.4 times by 1.9 times by sine of this angle. 0.584243. Right? So we save this. So 0.5 times by 3.4 times by 1.9 times by sine of answer, we get 1.782. Area we needed in 3 significant figures. Okay, so 1.78. Okay, given that the ratio of the area of the sector OABC to the area of the triangle OAB is 3:2, show that the angle BOC is 0.462. Okay. So first off, we write this as the ratio. So triangle BOC, sector OBC, area OBC ratio area OAB, they gave us to be 3/2, right? 3/2. Yes, okay. Wait, sorry, first let's write 565 1.78. Okay. So area of OBC, area of sector OBC would be 3/2 of this thing, 1.781565. So this times by 1.5, you get 2.672347. Okay, so these are intermediate answers. We need them in more decimal places, more significant figures. So we need the angle BOC, right? So this is also equal to half r squared theta, right? So half 3.4 squared times by theta in radians, or you can say angle BOC, so let's leave it at angle. Let BOC angle equals to theta radians, 2.672347. So this times by 2 divided by 3.4 squared, you get 0.462. And we needed this in 462? Yes. Correct to 3 significant figures. So angle BOC equals to theta. This is radians. Okay, hence find the perimeter of the badge in centimeter to the nearest integer. Okay, so for the perimeter we need a few things. So for the perimeter we need this length. This is 3.4. This is 1.9. This is known. What items do we not know yet are this arc length CB and this OA. Okay, so we need to find these. So D part R theta, simply R times by the theta BOC that we have found out, 0.462343, let's say 4. So this times by 3.4, this is your 1.571969. Next up we need the length OA. So OA is opposite to this particular angle, which we found to be did we find OB? Yes, we found OB to be this particular angle. Okay, or let's simply use the exact form. Okay. 0.584243. For 584243, right? And the other opposite pair was 1.9 and pi by 6. Right. Okay. So OA would therefore be 1.9 times by 2, because sine pi by 6 is 1 over 2 itself. So times by sine of 0.584243. This is going to be 2.095959. Right. Okay. So hence the perimeter would be OA plus the arc length 1.571969. We had 3.4 and 1.9. Okay, so this plus 1.571969 plus 3.4 plus 1.9. So you get 8.9679. So to 1 centimeter, so correct to the nearest centimeter, they said, right? To the nearest integer. So 9 centimeter. Okay, so that's it. 9 centimeter. Okay, so let's move on to the next question. Question number 9. express 6x minus 27 over 4 minus x squared to be in the form of a plus b x plus c whole squared. Okay, so first let's rewrite the same thing. You have six x minus 27 over 4 minus x squared, and we need this in the form a plus b x plus c whole squared. Okay, so completed square form basically. So what we can do is we can rewrite that as minus x squared plus 6x minus 27 over 4. Okay, so remember, this is the square that we need to complete. So minus brought out. Minus brought out. Simply this becomes x squared minus 6x minus 27 over 4. Now we complete the square inside the brackets. This would be x squared minus 6x plus 3 squared minus 3 squared, because 6 divided by 2 is 3, minus 27 over 4. So one thing to remember, this minus will also multiply with this minus 3 squared, okay, to bring it out. So you will have minus x minus 3 whole squared minus minus, this will become plus 9 minus 27 over 4. To simplify this, we'd multiply by 4, multiply by 4. So 36 minus 27. This becomes 9 over 4 minus 9 over 4. Okay, so this is the completed square form for this function. Wait. Oh, this was plus now, so sorry, yes, 36. So this is going to be plus, right? Okay, so you can write it in that form: 9 over 4 minus x minus 3 whole squared. Okay, so that is the form now. Given that, figure 2 shows part of the sketch of the curve C1 with the equation 6x minus 27 over 4 minus x squared. C1 is the parabola, right? Quadratic equation. Given that point P is the maximum point on C1, state the coordinates of P. Okay, so first off, we need dy by dx. So, so dy by dx, we can differentiate this thing if you know a little bit about the chain rule. So derivative of 9 over 4 is 0, minus 2 comes down, x minus 3 multiplied by the derivative of x minus 3, which is just 1. Okay, that would have gotten you the same thing by if you had just done this, if you have just differentiated this thing. So 6 minus 2x. So if you do this, this is still 6 minus 2x. So basically the same thing. Okay, so we need at P, this 6 minus 2x is equal to 0. So therefore x is equal to 3, and y would therefore be this thing, 9 over 4 minus, would be just that, because in completed square, remember, this particular value, this constant value, represents the peak. Actually, we did not need to use that. Oh sorry, I forgot. I forgot that we had already did the completing the square. So the coordinates were like staring us right in our face. Okay, so this is the coordinate. So 3 and 9/4. Okay, so actually we did not need that. We could have just stated that from over there. Okay. Figure 2 also shows part of the sketch of the curve C2 with equation y equals to cos of kx. Okay, where k is a constant and x measured in radians. Given that C1 and C2 intersect on the x-axis at point A and point B, shown in figure 2, state the x coordinates of B and state the value of k. X coordinates of B. Right. Okay. That means we need to find out the roots for this. So 9/4 minus x minus 3 whole squared equals to 0. So this becomes x minus 3 whole squared equals to 9/4, which becomes x minus 3 equals to plus minus 3/2. So this means that x is 3 plus minus 1.5 or 3/2. So the point A would be 3 minus 1.5, which is 3/2 or 1.5 itself. And the other one, B, would be 3 plus 1.5, which is going to be 4.5, 9/2. So either way you can do that. So state the x coordinate of, we needed to show that, that's what we have done. State the value of k. Now the cos kx is intersecting at these points, right? So remember, for the cosine curve, at 0 it's 1, at pi by 2 it's 0, and then again 3 pi by 2 it's at 0 again. So this kx corresponds with pi by 2 or 3 pi by 2. So cos of kx equals to 0. So that means kx is either pi by 2 or kx is 3 pi by 2. Right. So we know the x values now. Say the value of k. Okay. We know the x values. So x values are 1.5 and 4.5. 3 by 2, pi by 2, or it should come out to be one value, 9/2, 3 pi by 2. So 2 and 2 gets cancelled, 2 and 2 gets cancelled. So notice both ways you're getting k is equal to pi by 3. Both ways. This is 3 pi by 9, which is also 1/3 pi. Okay. State the period of C2. So period is determined by simply dividing this by 2 pi. So once again, pi gets cancelled. 2 times by 3 is 6. Okay. The line segment L joins P and B, right? So this is your P and B, okay? The region R, shown shaded in the figure 2, is bounded by L, C1 and C2. Use inequalities to define R. Okay, so let's see this. So it's bounded by the line, the curve. Okay, so bounded by the lower than this, less than equal to 9 over 4 minus x minus 3 whole squared, greater than the cosine pi by 3 x, and less than PB. So that means we need to know the line equation, right? So this was at 3, this point was at 3, 9 over 4. This is 0, 3 pi by 2. So we can just find the line equation, and that would be this, right? So first off, let's write over there. So line joining P and B. So P is 3, 9 over 4, but B, remember in the cosine function it is kx, right? It's kx. K itself is pi by 3. Okay? So the kx is 3 pi by 2, right? So this means that pi by 3 times by some x is 3 pi by 2. So this means that what you have is pi cancel. So x is 9 over 2. Okay? So 9 over 2. So this is your 9 over 2, 0. Okay. So now we find out the y is equal to y1 m x minus x1. So I think this should be pretty straightforward. Y minus y1 is 0 minus 9 over 4 divided by 9 over 2 minus 3 equals to, now this was the gradient. This was the gradient, sorry. The y minus 9 over 4 x minus 3. Okay, right. So we just cross multiply now. I think we could like simplify this side first. So minus 9 over 4 divided by 4.5 minus 3, that is 3 by 2. So this becomes minus 9 over 4 times by 2 over 3 equals to y minus 9 over 4 divided by x minus 3. So 2 times by 2, 3 times by 3, so minus 3 by 2. So minus 3 by 2, x minus 3 plus 9 over 4, that is your y. So, sorry, simplify this further. So this is minus 3 by 2x plus 9 over 2 plus 9 over 4. So minus 3 by 2 plus 9 times by 2 times by 2. So 18 plus 9, 27 over 4. This is our line joining Pn. Hence the inequalities same as what we wrote above, y less than equal to 9 over 4 minus x minus 3 whole squared, y greater than equal to cosine of pi by 3x, and y less than equal to minus 3 by 2 plus 27 over 4. Okay, that's it. And yeah, so that's the D part. And that was the last part. Okay. And that's the end of this paper. I hope you enjoyed solving this question paper with me. If you have any questions, confusions, or doubts, feel free to reach out through the comments. Also, you're welcome to apply for May, June 2026 or October, November 2026 coaching programs one-on-one from the Patreon or from the simple link tree. You can access that. Until the next video, take care. Bye-bye.